welcome back to section 12.3. The next thing we're going to talk about is solving logarithmic equations. So, we know that if log base a of x equals y, then we can rewrite it in exponential form, a to the y equals x. In other words, when we're solving these logarithmic equations, one of the more helpful things that you guys can do is probably going to be converting it to exponential form. Because once it's an exponential form, well, sometimes you can just do the exponent if that's all you need. Sometimes you can, square root or cube root or whatever it is you need to do to get rid of that exponent. And so you're going to be able to solve it a little more easily from that exponential form. So that's probably going to be your first step. So let's give that a try. So in example 3, we're going to solve each logarithmic equation. The first one I have in part A is the log base 1/3 of 2x plus 5 equals 2. So the first thing I'm going to do is get it in exponential form. That's going to make my life a little bit simpler. So the base is 1/3, the exponent will be 2, and then it equals this middle part, the 2x plus 5. Okay? I can go ahead and do this. 1/3 squared. 1 squared is 1 and 3 squared is 9, so that's 1/9 equals 2x plus 5. Then I want to get the x by itself, so I'll subtract 5 from both sides. When I subtract 5, I notice this is a fraction, so let's go ahead and get a least common denominator. 5 is the same thing as 45/9, okay? So I'm just subtracting 5 from both sides. I'm just breaking that 5 into ninths so that I can go ahead and have a LCD over here. 1/9 minus 45/9 is negative 44/9. So 1 minus 45 is negative 44. You keep the denominator the same. On the right side, the 5's will cancel. You'll just have a 2x on that right side. And then the last thing I'll do is divide both sides by 2. And just remember that dividing by 2 is the same thing as multiplying by a half, which sometimes comes in handy when you're doing fractions, okay? So 2 divided by 2 will be 1x over here. On the other side, 2 and 44 simplify pretty nicely. I'll divide by 2 and divide by 2. So this would be negative 22/9 would be my x for this one, okay? Let's see, the next example I have in part B says that log base x of 5 equals 4. So this one, you notice I put the variable in a different place. It's in the base instead of kind of in that middle part. But it's going to be the same idea. I'm going to do exponential form first. So the base for my exponential form would be x, because that's the base of my logarithm. My exponent is right here. My exponent is 4. And it equals that middle part. It equals 5. Okay? Now that it's an exponential form, I want to get x by itself. And you're like, well, I need to get rid of the 4, right? So the opposite of the 4th power would be taking the 4th root. That would be the opposite operation. Whatever you do to one side, we should probably do to both sides so that we stay in balance. All right, so the 4th root and the 4th power will undo each other. You just have x over here. When you have the 4th root of the other side, you kind of have to think for a second, like, do I need a plus or minus or not? Well, it's an even root, so if I only do the positive 4th root, I would only get a positive x value. But could I have a negative x? Could that actually work out? Well, a negative times a negative times a negative times a negative still could give me that positive 5. So we actually could do the positive or negative 4th root of 5 and get 2 different answers that both would work in the context of this problem. You don't usually see negatives for bases, but, it could work. Now it's your turn. You all get to try one and show me how much you've learned.